and welcome back to Teacher Gimble's channel. Today we're going to be talking about Illustrative Math, Algebra 2, Unit 1, Lesson 9. Let's get started. Problem 1. A party will have a hexagonal table placed together with space for one person on each open side. So a hexagon has 6 sides, which means 1, 2, 3, 4, 5, 6. People can, actually not 6 people because it looks like they're put together like this, can sit at each table. So complete the table showing the number of people who can sit at end tables. Well, at one table, it can be 6 people. And then at 2 tables, it's not going to be 6 people. It's going to be 1, 2, 3, 4, 5, and then 1, 2, 3, 4. And then an extra on that side will actually be able to sit there. So we're going to have 5 on the first table and 5 on the second table. So that's going to be 10. For 3 tables, well, we're going to have 5 for the first one, 4 for the second one, and 5 for the third one, which makes us 14. For 4 tables, it's going to be 5 on the first one, 4 on the second one, 4 on the third one, and 5 on the last one, which is 5 plus 4 plus 4 plus 5, which gives us 18. So I'm looking for a pattern here. I'll notice 6 to 10 is plus 4, 10 to 14 is plus 4, 4 to 18 is plus 4. So the fifth table, I'm going to say is plus 4, which 18 plus 4 is 22 people can sit at that table. Number 2, describe how many people who can sit at the table changes with each step. Well, the number of people that can sit on the table, or the additional number of people that can sit at the table each time, is plus 4, plus 4, plus 4. So if 4 additional people can sit, then you add an extra table. 3, explain why P of 3.2 does not make sense in this scenario. N represents number of tables. We do not have 3.2 tables, so 3 of 3.2 would mean how many people could sit at 3.2 tables, and that does not make sense. 4, define P recursively, and then for the nth term. So recursively means for one table, we're going to have P of 1 is equal to 6. So our function is going to be P of n is equal to P of n minus 1 plus 4. So it's going to be P of n minus 1 plus 4. And if you need help with how we define these functions, I recommend you go back to past lessons so that you can see how we've done this in the past, because we explain it a lot in the lessons that come previous to this. We defined this recursively right here. So before we go on to the next question, we want to figure out what is P of n where we don't have this extra function in here. Well, just like we talked about last time, we're going to replace the first term with the first amount that we have, which is going to be 6. And 6 people can sit at one table. And then we're going to add as many times the number of tables that we add on to that function, which gets of P of n is equal to 6 plus 4n. So there are 2 different ways of defining the same function. Let's go on to the next question. Question number 2. Diego is making a stack of pennies. He starts with 5 and then adds them one at a time. A penny is 1.52 millimeters thick. Complete the table with a height of the stack, h of n, in millimeters after n pennies have been added. Does h.52 make sense? Explain how you know. So, with 0 pennies, h of n is 7.6. So I guess that's where because that's this height of 5 pennies already. And then for 1 additional penny, we're going to add 1.52. So if you need to pull out your handy dandy calculators right now, I would recommend you pulling out your calculators to make sure that you are adding this correctly. Now, if you are good at that mental math, which hopefully a lot of you are, you could also do this in your head if you'd like. So find the value of 1, we're going to add 1.52 to 7.6, which gets us 9.12. The next term, we're just going to add 1.52 a second time. To do that, we get 10.64. Now we're going to add it again, which gets us 11.16. So those are our table values. Does h of 1.52 make sense? Well, what we're plugging in is number of pennies. We do not have 1.52 pennies, so no, h of 1.52 does not make sense. Problem 3. A piece of paper has an area of 80 square inches. A person cut off 1/4 of the piece of paper. Then a second person cut off 1/4 of the remaining paper. A third person cut off 1/4 of what is left, and so on. Complete the table where A of n is the area in square inches of the remaining paper after the nth person cut off their fraction. So the person cut off 1/4. 1/4 of 80 means there's going to be minus 20. The way we can think of it is minus 20 because 20 is 1/4 of 80. But what I'm going to think about this is I'm going to use my fraction sense here, and I'm going to say if I get rid of 1/4, what I am left with is 3/4 of what's left, because that way I'm just multiplying by the same term every time. So instead of saying, oh, what's 1/4 and then subtracting 1/4, I'm just saying we have 3/4 of what is left. Now you can put that in a calculator as 3/4 or 0.75 because they are equivalent fractions. So whichever you're more comfortable with. But it's really important that you start understanding the number sense with the fractions in order to keep doing your calculations. So 3/4 of 60 is 45, and then 3/4 of 45 is 33.75. So we have completed the table. Define A for the nth term. So A for the nth term is area after n people cut off 1/4 of the remaining paper. What is a reasonable domain for function A? Explain how you know. Well, A is going to range somewhere between 80 and I would say 0, but I would say actually 0 is less than or equal to x is less than or equal to 80, because we start with 80 and we're going to get all the way down to maybe about 0. What we could actually do is say, okay, well, the paper's never actually going to go to 0, so just have it always greater than 0. And that's actually a calculus fact that you'll learn someday, but not yet. And we're done. The domain is x is in between 0 and 80. Let's go on to the next question. Problem 4. Here's the recursive definition of a sequence. F of 1 is equal to 35. F of n is equal to the previous term minus 8 for n is greater than or equal to 2. List the first 5 terms of the sequence. Well, the first term is 35, then we're going to be subtracting 8 each time, so 35 minus 8 is 47, minus 8 is 39, minus 8 is 31, minus 8 is 23. And let's graph the value of each number. So the first term is 35, then 47, and I did this wrong. I said 47 and not 27. And that's okay. We all make mistakes. So if you caught that, that's really good that you caught that before I did. So we start with 35, minus 8 is 27, minus 8 is 19, minus 8 is 11, minus another 8 is 3. So the first term is 35, 27, and half of mathematics is learning how to make mistakes and learning how to correct those mistakes. So it should never be something that you're worried about making mistakes. The goal is always to be able to correct them. All right, we have our function. This is a straight boy, so we know he's an arithmetic function, also because we're subtracting the same number every time. All right, next question. Here's a graph of sequence Q. Define sequence Q using function notation, recursively using function notation. Well, Q, our first term, is -3. So our nth term, that's a Q, is going to be -3. It's an arithmetic function plus whatever the previous term was. All right, we're done. I flip these two. Usually I write them in the opposite direction, opposite sides, but addition is communicative, so it doesn't actually matter which order you write them in. They're both the same thing. Let's go on to the next question. Problem number 6. Here is a recursive definition for a sequence. So, sequence F. F of 0 is 19. F of n is going to equal f of n minus 1 minus 6 for n is greater than or equal to 1. The definition for the nth term is f of n is equal to 19 minus 6 times n for n is greater than or equal to 0. That's a mouthful. Let's read the questions to figure out what they're asking us. Explain how do you know that these definitions represent the same sequence? Well, looking here, I see that the first term is 19, and we are going to be f of 0 is 19, and then the rest of the terms are going to be defined by the term before minus 6. So this is the way that I'm defining my function right here. Now, how do I know this guy is equal to this guy? Well, I know that as n goes up, I'm going to be multiplying 6 several times. And the way that I write multiplying 6 several times is 6n. And that's where I got that from. I know my first term is going to be defined based on the 0th term. And the 0th term is 19. And that's why that's right there. And in that way, I know that they are the same function. 2. Select a definition to calculate f of 20 and explain why you chose it. Well, if I was using this top definition, I'd have to calculate 20 values in order to figure out what f of 20 is. But this bottom definition, all I need to do is plug in 20, and it makes my life a whole lot easier. So instead of the n in this case, I cross them out and I write a 20. 6 times 20 is going to be 120. 19 minus 120 is 101, and I'm done. Well, it's negative 101, and I'm done. Problem 7. An arithmetic sequence J starts 20, 16. Explain how you would calculate the value of the 500th term. So 20, 16, 12, ... and I know that because I'm subtracting 4. So to define it recursively, I would say J of n is equal to J of n minus 1 minus 4. Now in this case, this is my first term. But I could say my 0th term, as we've been talking about 0th, it would be 24 in this situation. So if I want to go from this notation to that notation, I would say J of n is going to be our 0th term, which is 24, plus n times. So it's going to be plus negative 4 n times, which is the value of our place value of what number we're looking for in the sequence. So if we're looking for the 500th term in this case, I would say J of 500 is equal to 24, plus negative 4 times 500, which I'm going to leave to you to put in your handy dandy calculator, and that's how we calculate it. If you have any questions, make sure to put them in the comments below. Hopefully you like this video, and like and subscribe so I can continue to see you in the other ones. Bye.